Alright, in this lesson we're going to learn about triangle congruence and how to find if two triangles are congruent, or what is given when we know that two triangles are congruent. So let's go ahead and get started here. Okay, so how can we prove if triangles are congruent? Well, first of all, we need to know how many parts there are. How many parts do congruent triangles have? Well, we all know that a triangle has three sides and three angles. So for triangles to be congruent, all three pairs of congruent sides need to be congruent, and they need to have the same measure. And also all three pairs of angles need to also be congruent. They need to have the same measure. Let's look at an example here. We have two triangles, triangle BAT and triangle ICE. Now, in these two triangles, I've given you all of the parts that are congruent. For instance, I've given you that segment BA is congruent to segment IC, segment AT is congruent to segment CE, and segment BT is congruent to segment IE. Those are the three pairs of congruent sides. Okay? The little tick marks there show you that they have the same measure. They're congruent. Well, besides having the three pairs of sides congruent, we also need the three pairs of angles congruent. So angle B is congruent to angle I, angle A is congruent to angle C, and angle T is congruent to angle E. So since we have all three sides and all three angles congruent to each other, we can make a congruence statement. When a question asks you to make a congruent statement, it's asking you to say triangle so-and-so is congruent to triangle so-and-so. Now the order does matter here. Okay, so if I say B, we know that I corresponds with B. If I say BAT, then I have to say ICE. And as I just said before, the B corresponds with the I, the A corresponds with the C, and the T corresponds with the E. Now if you notice in the sides and in the angles, everywhere I put a B, I also put an I, same position, because they correspond with each other. Everywhere I put an E, okay, a T corresponds. Everywhere I put an A C corresponds. A and the C corresponds. So the corresponding parts need to match up, and order matters in all situations. Okay, let's reverse it here. Let's say that I give you a congruent statement, such as triangle ATL is congruent to triangle DEN. Okay, no picture here, but we are given a lot of information just based on the congruent statement. So from the congruent statement, can you find the congruent parts given the following statement? Remember that order does matter. And also remember that CP-CTC, corresponding parts of congruent triangles, are congruent. So from this statement, I need for you to list the pairs of congruent sides. There should be a list of three, and also the pairs of congruent angles, which there should also be three. So pause the video now and write those down. Okay, so based on the congruent statement here, we should come up with the congruent sides, and we remember that the A corresponds with the D, the T corresponds with the E, and the L corresponds with the N. Those vertices match up, as well as combinations for the sides and the angles match up. So here's a list of sides. We have segment AT is congruent to segment DE. Now if you put segment TA congruent to ED, you're also correct, because the order matters. The A matches with the D, and the T matches with the E. On my list I also have segment TL is congruent to segment EN, and segment AL is congruent to segment DN. The list of angles, very easy. Angle A is congruent to angle D, angle T is congruent to angle E, and angle L is congruent to angle N. This is based on the fact of corresponding parts of congruent triangles are congruent. I stated that earlier. This is a rule, the mathematical way of saying that if the whole thing is congruent, then the parts are congruent. So the corresponding parts, the matching parts of the congruent triangles are also congruent. So if you have the whole thing, you can say each of these 6 items. What if I give you two triangles and I ask you to find out if they are congruent? Well, is there an easy way to say that the two triangles are congruent without finding all 6 parts? The answer is yes. And there's 4 congruence theorems here that help us to take a shortcut. Instead of finding 6 parts congruent, we're going to find 3 parts. And the 4 items here are SSS, SAS, ASA, and AAS. And we're going to go through each of those now. Alright, the first one is side, side, side. What side gives us or tells us is that if all three sides of a triangle are congruent to the three sides of another triangle, then the triangles are congruent without knowing any angle measures at all. Here's an example. You see here we have segment HO is congruent to segment SU, OP congruent to UN, and HP congruent to SN. Now we can say that these two triangles are congruent automatically just based on the sides. So we say triangle HOP is congruent to triangle SUN by the SSS theorem. All right, the next one is SAS, side angle side. If two sides and the included angle, now that's the key part. The included angle is the angle in between the two sides that you have. If we have two sides in the included angle and they're congruent, then we can automatically say that the two triangles are congruent. In this example here, we have AM congruent to OJ and AN congruent to OB, and then we have angle A congruent to angle O. And notice where A and O are located. These are called the included angles. Okay, angle A and angle O are in between the two congruent sides. So based on that, we have SAS, and we can say triangle MAN is congruent to triangle JOB. Order matters. Make sure you follow the pattern there. You could name these differently, but of course it's kind of neat here with the naming of the letters making little words. But you could say NAM, and if you say NAM, then you must say BOJ. All right, the next theorem says angle side angle, ASA. Angle side angle says that if two angles and the included side, that is the side that's between the two angles, if they are congruent, then the triangles are automatically congruent. So this time, instead of having an included angle, we're having an included side. Okay, angle B and angle E are congruent here. Angle C and F are congruent. And then you see that BC and EF are congruent, and the sides are in between the two angles. So angle, side, angle. These are the included sides. And the congruent statement says triangle ABC is congruent to triangle DEF by the ASA theorem. All right, the last one is angle angle side. Now, angle angle side has two angles on the side, but the side is not included this time. So if two angles and the non-included side, a side that is not between the two angles, if they are congruent, then the triangles are automatically congruent. All right. Before, I didn't talk about switching the order of the theorem because the order didn't matter. SSS becomes SSS if you flip it around. ASA, SAS, flip those, you get the same thing. But in this case, angle angle side, you can flip it around and get side angle angle. Just understand that that means the same thing. Okay. So here's an example. We have angle angle side, angle angle side. So we see that the side is not included this time. It is the non-included side. It's not in between the angles. But angle angle side is a good theorem, so we're going to say triangle FGH is congruent to KJI by the angle angle side theorem. Okay, so I've given you the four that work. What does not work? With combinations of A and S, there's a couple that will not work. And in a future video, you're going to get a visual proof of why these do not work. But let me tell you what they are first. The first one is, a good way to remember, is that no batteries. Angle, angle, angle. What do I mean by that? If you say angle, 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 that's AAA or AAA, and that's a battery. So no batteries. And also, no bad word. The bad word is obviously a combination of A and S that I'm not going to say, but you can get that. It's angle side side, or if you flip that as side side angle. Okay, so no bad word and no batteries. If you remember that, you'll be good to go. SSS, SAS, ASA, AAS, no bad word, no batteries.